Now, this is a typical representation of a forced draft air cooler. We have the fan below the tube bundle. So it means that the fan is always sucking ambient air from the atmosphere and pushing that air through the tube bundle. The hot air, the air that is leaving the tube bundle after exchanging heat with the process fluid, the hot air is leaving from the top of the tube bundle. So in a forced draft unit, the fan is pushing ambient air through the bundle and the fan is always exposed to only ambient air. As against this, in an induced draft unit, the fan is always mounted above the tube bundle. The fan is still sucking air, but it is sucking now hot air because cold air from below the tube bundle is passing through the tube bundle, and the hot air from exit of the from the top of the tube bundle is what is going to the fan suction. So the fan is always exposed to a higher temperature in case of induced draft units. So this has some considerations for the fan blade material selections and any other instrumentation and control items which you can have on top of the induced draft cooler units. So there are considerations for the air exhaust temperature in induced draft units if we have some downstream equipment or instrumentation on the induced draft unit. Now, this is a natural draft unit where there is no fan involved. Now, if there is no fan, how does the airflow occur? The airflow occurs because of the chimney effect. In a natural draft unit, there is a chimney on top of the tube bundle, and the temperature difference between the hot air inside the chimney and the cold air outside the chimney, the cold ambient air outside the chimney. This is what sets up a flow of the air through the tube bundle and the chimney. So the airflow occurs because of density differences between the hot air inside and the cold air outside the chimney. And that is how a natural draft unit would work. So natural draft units are used, but they have limitations on what is the amount of duty which they can handle. It's not that you get any cooler which you do for a as a forced draft unit, a big cooler for the 100% duty. You will not be able to achieve 100% duty in a with a natural draft cooler. It is possible theoretically, but it would require a huge amount of area to achieve that same duty if you're talking about doing it in complete natural draft unit. So natural draft units have limitations on what is the maximum duty which is economically feasible. Yeah, there are a few other variants in air-cooled heat exchangers. The variants can be based on the type of headers, the type of fins, the type of drive systems, or the type of air recirculation systems which may be required in some of these units. Then we always hear the word air cooler, where we are saying that the process fluid is cooled by using ambient air. So we are using air to cool, so we are calling it as an air cooler. But there are instances where ambient air is also used to heat another fluid. There's particularly the application when you talk about large LNG stations, where the process fluid is actually at a much lower temperature and it needs to be heated up before it goes into your distribution network. So in such cases, we use ambient air to heat that fluid. Like if you have your fluid at say around -20, -30 degrees centigrade, instead of using any other type of heat exchanger or the utility stream, we can always use ambient air to heat that process fluid. Of course, there are some additional considerations which you have to account for when we do these. And typically such units are called air heaters because we are using ambient air to heat that fluid. So the particular problems which we face in such unit design is that ambient air has some humidity, it has some moisture content. So in a air heater, the ambient air is getting cooled down, unlike in an air cooler where ambient air is getting heated up during the process of heat transfer. In an air heater, the ambient air is getting cooled down. So the chances of moisture condensation, frost formation on the finned surface, these chances become very high. The probability of condensation of moisture and frost formation on the heat transfer surface becomes very high. So we need to see how we can address those issues. So that is a totally different type of air heaters which we design in some cases. The concept is the same, but you have to address these other issues like frost formation and moisture condensation.